Professor Daniel Mashao, Executive Dean, Faculty of Engineering and the Built Environment. Professor Lagouge Tartibu, our inductee today. Our respondent, Professor T.C. Jean, is joining us remotely, but we have a recorded speech. Senior leaders of the university, members of Senate and other academics, distinguished guests, all those who are joining us remotely. Sanibonani, Huyanant, good evening, Tober. A special word of welcome to Prof Tartibu's parents who are here with us tonight. You are welcome. It is indeed a great honor and a special privilege for me to welcome you to the Professorial Inauguration Lecture of Professor Lagouge Tartibu. As I do so, I wish to express a warm welcome to his loved ones, special guests, and colleagues. This is indeed a proud and joyful, yet a landmark moment for all of you. Prof Tartibu, for us here at UJ, for higher education in South Africa and beyond. The inauguration of professors is a public ceremony in which newly appointed professors are inducted into office by the Vice Chancellor and deliver their inaugural addresses. The ceremony has its roots in the medieval university and serves multiple purposes. First, it is an expression of welcome and an entry for new professors joining the circle of colleagues who are already professors. Secondly, it provides a platform for professors to display their expertise in the discipline and showcase their research. In tradition subscribed to by many universities, assuming the role of the professor refers to the gown and the cap. Once we have listened to the inaugural address, the gown denoting professorship will formally be assumed. Today we gather to witness Professor Tartibu's entry into the illustrious community of scholars at our university. It celebrates his contribution to his discipline and ultimately his impact on society. Professors provide a university with its identity, character, academic legitimacy, and integrity. The inaugural lecture is a rite of passage following the confirmation of the appointment of a person as a professor. This evening we will listen to Professor Tartibu as the gown goes to town. By this I mean that the power of the inaugural address is when the expertise is showcased beyond the corridors of the university and reverberates throughout society. It stands out as a moment of pride for the incumbent, the family, fellow scholars, the university, and ultimately society. In the past, several philosophers and scholars have defined universities using very narrow conceptualizations. For example, the search for truth, for universal knowledge, and even as instruments serving the purpose of the economy or being utilitarian in nature. Through our work and research at UJ, I hope that we can break out of these narrow conceptualizations and reflect on the university as contributing to the public good, working towards societal impact. What is the role then of the intellectual? Edward Said, in one of his articles, defines the role of the intellectual as, and I quote, one who commands a vast knowledge of a specific discipline, one who is rigorous in the analysis of literature, who views being an intellectual as a vocation, and who functions as a kind of public memory to recall what is forgotten or ignored, to make connections that are otherwise hidden, and to provide alternatives for mistaken policies. It remains then for us, as a university with a Pan-African vision, to derive our mandate as intellectuals and professors. And importantly, how do we embrace the role of a professor as disruptors while continuing to be flagship carriers of our disciplines? This evening, we will listen to Professor Tartibu as one further step in the journey of being a professor. This is a journey which does not conclude once this lecture has been given. Notwithstanding, this inaugural lecture does create an opportunity for self-reflective pause in the journey of the professor. Let me now invite the Executive Dean, Professor Daniel Mashau, to introduce Professor Lagouge Tartibu. Professor Daniel. Thank you, ladies and gentlemen. Dear ladies.
Good evening. It gives me great pleasure this evening to come and welcome Professor Tartibu to the professorship as our inductee this evening. I will be going through his history. You will realize that he has a very colorful and excellent CV that he has collected over the years. He has not only been to Johannesburg, but also to Cape Town towards the end of Africa, and now in the middle. Professor Tartibu earned his Bachelor of Engineering in Electromechanical Engineering, a 6-year qualification from University of Lubumbashi in 2006. During his undergraduate studies, his primary research interests were centered on vibration, modeling, modal testing, simulation, and computer programming. Notably, as part of his undergraduate project, he developed a MATLAB program for predicting the vibration of rotating machinery. And for his master's, he worked on a variable blade length wind turbine. In recognition of his contribution to the field of computational and applied mechanics, he was honored with a Master's Student Prize by the South African Association for Theoretical and Applied Mechanics in 2006. Prof. Tartibu successfully attained the doctorate degree in mechanical engineering in 2014 from the Cape Peninsula University of Technology with a specialization in thermoacoustics. Notably, he developed and implemented this multi-objective methodology within the general algebraic modeling system, enhancing his expertise in engineering optimization, as you will see at the title of his talk. Aligned with the research agenda of the University of Johannesburg, his research endeavors have embraced the integration of machine learning techniques for modeling, analysis, and predictive analytics related to the performance metrics of engineering systems. Professor Tartibu's contribution to the field are also reflected in his co-authorships of 2 books with titles Meta-Heuristic Optimization and the other book, Modern Optimization Techniques for Advanced Machining. Professor Tartibu's academic journey commenced as a junior lecturer in July 2007 at the Cape Peninsula University of Technology. In January 2018, he embarked on a new chapter of his career, joining the Mangosuthu University of Technology. In 2015, Professor Tartibu joined the University of Johannesburg as a senior lecturer, then promoted in 2018 as an associate professor, and again in 2022 promoted to full professor. Over the years, Professor Tartibu has guided and mentored several students, supervising them to completion. To this, he has done over 100 design projects, produced over 50 master's students, and supervised 7 doctoral students to completion. His dedication to this field were further recognized in 2018 and also 2019 when he was awarded an NRF rating. Professor Tartibu's contributions to academia are underscored by a portfolio of over 200 publications on Google Scholar. The body of his work comprised 120 journal articles, 4 book chapters, 2 authored books. Additionally, he has played a collaborative role in the development of 1 patent stemming from a final year design project. These contributions have garnered substantial recognition, with his research accruing over 1,261 citations and achieving an H index of 19. Professor Tartibu's research endeavors benefit from the generous support of institutions, including the National Research Foundation, DHET, and the University of Johannesburg. In addition to this research output, he maintains active affiliations with many organizations in the country that are in the field. Colleagues, I'm here with you today to hear the inaugural speech by Professor Tartibu.
Thank you very much, Prof. Mashau, Dr. Valipata. Thank you so much. I want to acknowledge the contribution of the University of Johannesburg through you and through my line manager, Dr. Mashinini, Professor Mashinini, and Dr. Ngibani. So thank you very much, ladies and gentlemen, and esteemed colleagues, honored guests, and members of the academic community. I stand before you today with deep humility and a profound sense of responsibility as I embark on this journey. It is a great privilege to be here, and I'm truly honored to address you on this occasion. So this professorial inauguration marks a pivotal moment in my academic career. So today I would like to share with you some insight into my academic journey, so the path that has led me to this moment, and the aspirations and the contributions I hope to bring to our institutions. So my presentation title is Evolutionary Algorithms, so the key to cutting-edge engineering optimization. So I will start with a short biography, and I will end with some thoughts on so what will be the way forward, so from this point on. So my biography, so I'm not going to mention so the title, it was already mentioned by the Dean. So I'm married to 1 wife, and I've got 2 kids. I've got 4 kids, so 2 introverts and 2 extroverts. So I am from an ethnic tribe, which is called Emba. And I'm sure so today is an honor also for the people I belong to, so to witness so this specific achievement. So when you look at Wikipedia, so the name Bahemba so refers to those who exercise patience. So my background, I am an alumni of the University of Lubumbashi in the Democratic Republic of Congo. I am also an alumni of a famous high school, so which is called Institut Technique Mutoshi. So I completed my doctorate degree at Cape Peninsula University in 2014, and I'm also an alumni of that institution. So as for my career, so I started as a junior lecturer in 2007, and I was promoted full professor in 2022. I am affiliated with a number of organizations, and I'm also a visiting professor for a number of universities. I will simply mention the University of Lubumbashi, so the university that groomed me, and also the University Mapon. I'm affiliated with organizations such as the American Society of Mechanical Engineering, so the South African Institute of Mechanical Engineers. I will simply speak about my beliefs and my philosophy. As a teacher, so my teaching philosophy is built around my belief that teachers must inspire learning by empowering learners. So students are much more likely to succeed when they are allowed to take ownership of their learning. So therefore, my primary role as a teacher is to excite learners' passion for learning by creating a supporting environment. So when it comes to leadership, I have a strong view. So all leaders have one thing in common, which is followers. And followers are people who generally freely will follow you. So they will voluntarily follow you. So there are two ways to maintain followers. So either you inspire them or you incentivize them. So the second option is generally not sustainable. Now I will now go on and speak about some of my research and scholarly achievement. So it was listed before. So I have published over 190 documents on Scopus and on Google Scholars. So I have 220 publications. So to date, I have supervised to completion over 50 master's students and 7 doctorate students. So looking at my profile, so it appears that my strengths are basically in computer science and in engineering. So my field of expertise are in thermoacoustic, in engineering optimization, in applied thermal engineering, mechanical vibration, and artificial intelligence. So there are two documents that features prominently on my profile. So the first one is a book which titled Meteoristic Optimization, Nature-Inspired Algorithm, Swarm and Computational Intelligence. So in that specific book, I describe the use of meteoristic and illustrate how these approach could be used to solve optimization problems. In the second book, with titled Modern Optimization Techniques for Advanced Machining, so the focus for the book was to tackle the issue of machining performance and illustrate how meteoristic approaches could be used to formulate multi-objective problems and compute parameters that describe machine settings. Now my point of departure will be the complexity of the formulations of problems. And this comes from the fact that I have been taking the duty of teaching the subject of engineering design. So mechanical engineering design is a process. So basically what we expect from the student is for them to create from their mind. So ultimately, the purpose will be for the student to find the sizes and the specifications. Now here I will take you through some of the examples of accomplishment of an undergraduate student. The first one is a construction of a low-cost Stirling engine. So the second one is a powered portable trench digging machine. The third one is a solar power purification system. The fourth one is a grinder and a mixer for cement production. And then you have a sensor control convertible cart trolley. You also have a lightweight material handling, automated guided vehicle. And the last one is automated coconut scraping machines. Now, when I look at most of these concepts, so you will agree with me, so they are very complex. So, and the expectation that we have is for students so to be able to find the size and the specifications. Now, the question now is, how can you relate so the motion or the effort that is applied, let's say, on a specific system, so to the size and the specifications? And that is not a trivial problem. So this is why I highlight the importance of the formulation of problems in engineering. So just to illustrate what I'm talking about, so I have one concept which was developed. So it is a simple positioning system that utilizes a belt to drive a table. Now, in this specific concept, so there is a belt, which is shown on the figure, and looking closely, so at the length L1 and L2, so in the formulation of the problems, so we need to consider that the dynamic nature of the system, which stipulates that the stiffness of the sections L1 and L2 of the belt are going to change. Now that is why, most of the time, what we then do is having an actual engineering system, so you can convert it into a mechanical model or a mathematical model. So through numerical simulations, the proposed model, it could be analyzed, validated, and improved. Now, finite element method, is a popular method, for solving differential equations, because most of the problems that we face in engineering end up being differential equations. Now, using finite element method, we can then formulate the problem, and in this case, the geometry of the system is simply developed, and through simulations, the system could be analyzed, validated, and improved. Now, in summary, for this first section, developing mechanical and mathematical models of actual engineering system is increasingly challenging, and because of the complexity of a design concept. So the integration of mathematical modeling and simulations makes the formulation of the problems relatively easy. Now, I will take the case of thermoacoustic systems, which is part of my expertise. Thermoacoustic, just for the definition, is a field of science, which deals with the conversion of heat energy into a sound wave and vice versa. Now, you can convert heat into a sound, or you can make use of heat, to induce cooling. So based on that principle, there are two different concepts that can be developed. The first one is a thermoacoustic refrigerator. So basically, you have a loudspeaker, which is going to generate a sound wave, and the sound wave will be used for cooling. The second concept is a thermoacoustic engine. So you provide the heat on one side of the device, and you cool off the other side of the device. It is going to produce a sound wave. Now, these are simple concepts, but the difficulty now is, as we develop as researchers, we discovered, for instance, in the case of thermoacoustic, that the geometrical configuration of the system affects the performance. Now, because of that, we have developed a model, which is basically adjustable. So you have a system, from which you can adjust the length, to be able to change, the performance of the system. So what you have here is an adjustable system. So it is it has two different parts. So the first part of the system is basically going to produce a sound wave. And then this first part of the system is going to slide into a second part of the system, which is going to induce cooling. I will simply jump So to go to the section of cooling. Now I see the video has stopped. I will simply go to the next slide because the next slide shows how the model looks like. So this is a model that we have built, and the idea is to adjust the geometrical configuration of the system and then measure the performance of the system. So that is a typical engine, and this is a refrigerator. So recently, we have built a thermoacoustic generator. So basically, this is now a system which is going to convert a sound wave into electricity. Now, as we developed again, we have built a much more complex system, which is made of 4 stages. So with such system, we are able to reduce the amount of heat requires in order to generate a sound wave and then generate the electricity. Now the question is, how do you formulate the problem when you have such systems that are developed in the lab? So the step 1 is the formulation of the problem. Then we have to select a mathematical approach to solve the problem and then compute the result. So I will simply show quickly how it looks like. So this is you define the computational domain. In this specific case, you focus on the heart of the system, which is made of parallel plates. So the idea then is to be able to compute the parameters that describe the geometry of the system. Now, in order to compute these parameters, we have to measure the quality of each set of objectives by defining what we call objective functions. Now, in such problem, we have to extract equations, maximize some of the objectives while you minimize some other objectives in order to compute the best geometrical configurations. So in this case, this approach was implemented in the software GAMS in order to compute what is called the Pareto optimal solutions. Now in summary, developing more efficient thermoacoustic systems is closely linked to the optimization approach adopted. So using traditional approach, mathematical programming models could be developed. Now, optimal solution describing the best geometrical configuration could be extracted. However, this approach is challenging as the geometry of the systems becomes complex. Now, that is what has led us to machine learning, which is then the next part of my presentation. Machine learning is a AI techniques that teaches computing teams to learn from experience. So machine learning algorithms use computational methods to learn information directly from data, without depending on predetermined equation or as a model. So algorithms then improve their performance as the number of samples available for learning increases. Now, a short description of machine learning. So you basically have data. So you use data to build the model. And then there will be algorithms that will be used to train the models. And so you evaluate the solutions. When the solutions are not satisfactory, you have to analyze the error and then study the problem again. But when the solution is satisfactory, we can then deploy the model for specific applications. Now, using machine learning, for instance, for the case of thermoacoustics, what we have done is we have conducted experiment in the lab to extract the data. So in the case of thermoacoustic systems, the temperatures across each stages of the system were measured. And the idea was to compute what will be the output voltage. And then several different algorithms were used. In this case, it's artificial neural network. And adaptive neurofuzzy inference systems, hybrid artificial neural network, which is then hybridized with particle swarm optimization. So what you have on the screen is simply an illustration of the nature of the result we have obtained, which demonstrates the potential of the approach that we are proposing. So in summary, so through machine learning, models are developed using data. So there is no need to develop mathematical model. And the robustness of the models will depend then on the data. Now I will go into the next phase of my presentations. At this stage now I will speak about engineering optimization and the meta-heuristics approach. Optimizations actually means to find the best solutions among different possible solutions. So in general, there are too many solutions. When you optimize, you want to find the best among all alternatives solutions. Now, optimization algorithm is a procedure which is executed iteratively by comparing various results till the optimum or the satisfactory solution is found. Now, there are several optimization algorithms. Now, in my presentation, the word I've used is evolutionary algorithm. So in fact, it's simply, evolutionary algorithms, strictly speaking, is a part of meta-heuristic algorithm. But the meaning that I gave to the title of my presentation, I was referring to meta-heuristic algorithm because those are algorithms that evolve, and I will speak about it at the end of my presentations. Now, these optimization algorithms can be used for the formulation of the problem. And I have identified a number of algorithms in my presentations. The first one is the ant colony optimization algorithm. So if we look at a group of ants which are searching for the shortest path between their nest and a food source, so basically, that is what you see on the figure. In general, what happens with the ant is you have one ant that will locate the food. Now, as the ant explore the area, where they are located, they leave behind them chemical traces which are called pheromones, on the ground. So the other ants will follow these pheromones to be able to locate the place where the food are. So if the path is shorter and quicker, more ants will use it, leaving more pheromones, which makes that path even more attractive. So over time, the collective behavior helps the ants to discover the shortest path, and the most efficient route accumulates the most pheromones. Now, this is the behavior of the ant, and on this behavior, there is an algorithm that is built, and the algorithm is called the ant colony optimization. So in computer science, ant colony optimization applies a similar principle to solve optimization problems. So it uses artificial ants to explore potential solutions. So leaving a kind of a digital pheromones trait to mark the quality of each solution. So solution with higher quality, get more pheromones as more ants explore. So the algorithm converges towards the best solutions. So in a nutshell, ant colony optimization is like a swarm of virtual ants searching for the best solution to a problem by learning from each other's successes. So just as a real ant finds the best path to food. Now we have used the ant colony optimizations for a problem that is related to a picker. So you have someone who wants to pick some items in a warehouse. So what you have on the left-hand side represents the eye. I know these are small, represent the locations of different items. So the idea is to use ant colony optimization and identify the shortest path. So using ant colony optimization, the figure that you see in the middle represents the trajectory that we were able to compute using this specific algorithm. The second algorithm is a BAT optimization algorithm. So BAT algorithm is a nature-inspired optimization method that is based on the echolocation behavior of bats. So if we imagine a bat flying in the dark and searching for prey, in general, what they will do, so they will emit high-pitched sound or ultrasound, so that bounce off object and return as echoes. So by listening to these echoes, bat can determine the location and the distance of their prey. Now, in computer science, so in the bat algorithm, so we have a population of virtual bats. So each representing a potential solution to a problem. So these bats fly around a search space just like a real bat so do. So however, instead of emitting sound and listening to echoes, so they emit solutions and listen for the quality of those solutions. Now the BAT optimization algorithm was used to solve what is called the Weber function. So basically here we want to minimize the Weber functions, which is given by the equation that you see on the screen. So the idea is to minimize these functions. So we have built a model with 10 different BATs, and so after 1,000 iterations, so we were able to find the optimal solutions for this specific problem. The third algorithm is the whale optimization algorithm. So the whale optimization algorithm is based on the social behavior of whales in the ocean. So in the real world, so whales are known for their collaborative and synchronized hunting behavior. Now real whales swim through the ocean in search of prey. Now they work together to find and catch prey surrounding schools of fish, for example. So the key feature is that during the search, the whales communicate and collaborate. So if one of the whales discovers a prey, it shares the information with the other whales nearby. Now this is an illustration of how the whales catch fishes. So here the whale will go deep into the ocean and use bubbles to stun and trap the fish closer to the surface. So one whale generally leads, so the effort followed by the rest of the group. Now in computer science, in the whale optimization algorithm, so we will imagine that we have a population of virtual whales, so that represent potential solutions to a problem. So these virtual whales explore the solution space in a way that mimics the cooperative behavior of real whales. Now if one whale discovers a better solution, it shares the information with other whales nearby. So the algorithm balances exploration and exploitation. So the algorithm iterates over many cycles with the whales working together and gradually honing in the best solution to the problem. Now we have used the whale optimization algorithm to solve a problem that is related to machine performance. So the problem in this case here is in machining using a CNC machine. So the question is how to minimize, for instance, the surface roughness of a workpiece and how to minimize as well the cutting force. Now in this case, we have to extract the equations. And the equation in this case, these are we need to define the objectives, which are minimizing the cutting force and minimizing the surface roughness. So we now need to define the factors that affect the performance. In this case, it was the cutting speed, the depth of cut, and the feed rate. Ultimately, we want to compute the optimal solutions that characterize these parameters for the setting of the machines. So using response surface methodology, we were able to derive the equations and validate the equations experimentally. And this is simply an illustration that shows the best solution that was obtained through that process. And then a decision maker for a multi-objective problems need then to select the best solution, because when it comes to a multi-objective problems, the solutions are generally not unique. The fourth algorithm is the gray wolf optimization algorithm. So the gray wolf optimization algorithm is based on the social hierarchy and the hunting behavior of gray wolf. So in the animal kingdom, so the gray wolf are known for their structure and cooperative hunting strategy. So they work together as a pack with the alpha. So the alpha is the leader of the wolf, and the other members following its lead in hunting. So the wolf begin by randomly exploring the solution space, and the alpha wolf will guide the pack toward promising areas. So the key feature is that the wolf communicates and collaborates. So if one wolf finds a better solution than the alpha wolf, it takes the alpha's place as a leader. So the other wolf in the pack will adjust their position accordingly. So gray wolf optimization algorithm allows the agent to update their position according to the position of alpha, beta, and delta wolf, and to attack a prey. Now the gray wolf optimization in computer science is like a virtual pack of wolves collaborating to find the best solution to a problem. So these virtual wolves collaborate to search for the best solutions, just like the real wolf collaborate to hunt for the prey. So the algorithm includes a hierarchy of wolves with the alpha wolf as the leader. So the alpha wolf represents the current best solution in the search space. So the wolf will take turn leading, share information, and navigate the solution space, which help them converge towards the optimal solution. Similar to how a real gray wolf cooperates to hunt for food. Now this approach was used for the optimization of a solar-assisted combined cooling, heating, and power generation system. And the problems, the equations describing the metrics that describe the performance were extracted, using response surface methodology. So the problem here is formulated as, we seek to maximize the net power and maximize the exergy efficiency, and while you want to minimize the CO2 emissions. In this case, this is an illustration of the best solution that was obtained, and with this best solution, we are then able to find the best configuration that will achieve the highest performance. Now, in terms of a meteoristic algorithm, there are many. Yeah. In this slide, you have an illustration that shows different meteoristic algorithms. Some of them are based on physical phenomenon. Some of them are based on nature, on the swarm-based or biological phenomenon. Now, they have something in common, which is basically you have initial populations. So you can have an initial population of ant, initial population of gray wolf, or initial population, let's say, of whales. So basically, you adjust the parameters, and then you evaluate the objective functions, which you can derive, and then define, what are the stop criteria. So when optimal solution have not been obtained, we can still update and move to the next best solutions. And when that best solution has been obtained, then we can report that best solution as the optimal solution. The next slide here, is simply, I put this slide just as a word of caution, because the impression that can be created is to say, these algorithms are able to solve any problem. So the reason why we conduct research is because most of these algorithms are not suitable for any type of problems. So it requires research for us to be able to identify the algorithm that will give the best solutions. Now, in summary, reasons meteoristic approaches are cutting edge is because of their versatility, because they are highly adaptable and can be applied to a wide range of optimization problems. So they are also able to solve complex solution space, because most of the real problems are really very complex to formulate. So I will simply mention also they are able to solve most very hard nonlinear problems. So because meta-heuristic has been applied, so there are evidence in the literature that demonstrates the ability to solve those hard nonlinear problems. So meta-heuristic approaches continues to evolve and provide effective solutions so to increasingly complex and diverse optimization challenges. So my argument is the problem that we face as engineers are becoming more and more complex. So what we need now is to find algorithms that evolve like a meta-heuristics algorithm. Now, this is now the last part of my presentations. It speaks about collaborations, network, societal impact, and sustainability, and what we foresee as the next direction of research. Now, the first illustration that you see, this is a design project. So basically what we do now is we encourage students to develop a concept as part of a design project. And then, so through the university, so we secure a fund so for that specific project to be built. So this is a dehuling machine. So it's basically a machine that can remove, so it can be used to remove so the part of a seed that is not necessary. So second illustrations, so this is a small-scale wind tunnel. So that was built. It was developed as part of the design project and then built. And with such models, so we are able to validate CFD solutions, CFD models that we develop under the software environment. The third one, so this is a drone that was developed so for precision agriculture. Now, the smart weed detector so is able to selectively detect so any form of weed, and so the drone here will only release the pesticide when there is weed. So this drone was developed as part of a design project, and so the deep learning model was deployed on an embedded system which was mounted on a quadcopter. This is another illustration of so the impactful research, so which is the development of an autonomous wheelchair for disabled. So the idea is you develop it within, so as part of the design project, and then so we go ahead and build simple prototypes. So to increase the university impact, so this is one of so the advanced models of thermoacoustic systems, a refrigerator, so which actually features in the magazine, so Popular Mechanics, and that specific models were actually developed by a master's student as part of his project. Now, when it comes to thermoacoustic, the vision now is so to be able to build a system that is going to induce cooling and produce electricity at the same time. So that's really the vision, so that's where we are going. At this stage, we have mastered the technology, so we are able so to develop systems that are able to induce cooling and generate electricity. But at this stage, we want to use solar energy so to power the system. So this research is being done so in collaboration with the University of Campinas in Brazil. The next project in automotive sector so has to do with the fuel and emission saving technology. So as part of the collaborations, so we have been in collaboration with the company called Ducere, so for a number of years. So they have developed a concept which is called MISA. So it's a world-class fuel and emission saving technology, and which was deployed and retrofitted on a truck. So this is an example of the truck where the technology was deployed, and it can also be deployed on a full spectrum of vehicles. So the current challenges so that we are dealing with as part of a master's project is to focus on the hydraulic hybrid systems and be able to build a test bench and fit the necessary instrumentations so to replicate driving cycles. Now, one of the biggest projects that we have is to align the research with Sustainable Development Goals, because we believe that the Sustainable Development Goals are the blueprint for achieving a better and more sustainable future for all. So in this specific project, what we are trying to achieve is to harness the positive side of disruptive technologies, of the 4IR, and so in a sense, we want to build local expertise, and through a collaborative approach, so here we want to tackle the issue related to climate change. So this project is led by the University of Johannesburg, and it is done in collaboration with universities in Zambia, in Tanzania, in Nigeria, and also in Cameroon. The next part of the project that we have in mind is the development and the promotion of topological acoustic metamaterials. Metamaterials are engineered materials that have properties that you cannot find in nature. So they are used to transmit, trap, and amplify the sound wave. So an acoustic metamaterial is a material designed to control, to direct, and to manipulate sound wave in gas, in liquid, and solid. So you can see the strategy is to generate the sound wave and to make use of that sound wave to induce cooling or generate electricity. So this is the long-term plan. This specific research is being led by the CTU University in Hong Kong, and we, as part of, as collaborators with that university, so we focus on the issues related to optimization, so to enhance the properties of acoustic metamaterials. Now, in summary, so the challenges are many, and the expertise required is disseminated across the world. So collaboration is critical for the success of our ambitious ideas. So I have included this slide just to give a sense of such project cannot be done by a single person. There is many people within the organization, within South Africa, so within Africa and outside Africa, so we collaborate with. And so this picture is basically to also give a sense of I do work with people. So I present projects. Most of the pictures here, 80% of these people have already completed masters or PhD under my supervision. So, but these are the people I call my, these are my army. So the people I work with when it comes to projects. And now, as acknowledgement, I will conclude by that. So I wanted to start with my wife. And I've known this lady since my major achievement within South Africa. And she has witnessed my moment of extreme happiness and deep sadness. Now, she has celebrated my successes and stood by me through challenges and embraced the sacrifices that comes with academia. So today's achievement is not mine alone. So it's simply because I have to stand on the pulpit by myself. So the second set of people are my parents, and they are here. I want to honor them. So I value the teaching that focuses on the mind, but I value more the teaching that focuses on the heart. And I'm very grateful for the foundation of integrity. Now you have instilled into me the awareness that nothing meaningful can be accomplished without working hard. And I don't know any other way. So I will then also acknowledge my siblings and my families. So I mention them daily in my prayer. So their presence and their kind words have been a constant source of inspiration for me. So I thank them for the bottom of my heart for sharing this achievement with me. So I will also acknowledge my mentors and my colleagues. I am deeply grateful for the support and encouragement I have received from you throughout my academic journey. So your guidance and collaboration have been instrumental in shaping the scholar I have become, and for that I am thankful. I will also acknowledge my students. I know most of them are not here, but I will say it. The process is generally messy, but the reward is fulfilling. As a professor, so I have probably failed more than them. So what I mean is that I have made more attempts than them. So this explains why I have relatively more positive outcomes. So to all my friends, life looks better when you look at it in retrospect. So I would suggest that we continue to enjoy our achievement in retrospect. But at some point, we will have to bury each other's. But that is going to start in 50 years. Now to my kids, so I think no amount of success is comparable to what they represent in my life. So if I have to be known, for one single thing, so let it be, because I and their mother, have been great parents, to them. But last and not least, so I want to acknowledge God, because this is definitely not a testimony of my gift. So it's a testimony of God's grace. And I acknowledge all the people who have come to listen to this presentation and those who are watching online. So I'm really grateful. Thank you very much.
Ladies and gentlemen, distinguished guests, and fellow enthusiasts of engineering and innovations. Today we gather to explore a topic that lies at the very heart of engineering progress, evolutionary algorithms, the key to cutting-edge engineering optimizations. The world of engineering is a realm of constant challenges and advancements. We seek to create systems and structures that are safer, more efficient, and environmentally sustainable. At the core of this pursuit lies the art of optimizations, whether we are designing a skyscraper, perfecting a supply chain, or enhancing a manufacturing process. The quest is the same, achieving the best possible outcome. Professor Tartibu's presentation has highlighted the fact that in our modern worlds, the challenges of optimizations have become increasingly complex. We are dealing with intricate, multi-dimensional problems with countless variables, constraints, and objectives. Traditional optimization methods, while valuable, often struggle to navigate these intricate problem spaces. And this is where meta-heuristic algorithms emerge as the key to cutting-edge engineering optimizations. Before we dive into the profound impact of meta-heuristic algorithms, Professor Tartibu cautioned us on the fact that we need to ensure that we have a shared understanding of what they are. As highlighted in the presentations, meta-heuristic algorithms are a class of optimization methods that draw inspirations from nature's physics and social phenomena. They use heuristics to iteratively explore potential solutions to find the best one. Now, why do these algorithms stand as the way key to cutting-edge engineering optimizations? There are some key factors that can be extracted from Professor Tartibu's presentations. Flexibilities and applicabilities. Meta-heuristic algorithms are versatile. They are not limited to specific problem domains and they have been successfully employed in various fields, from engineering to finance, from healthcare to manufacturing. Global optimizations, unlike some other traditional methods that can get trapped in local optima, meta-heuristic algorithms are designed to explore and search the entire solution space, ensuring they have a better chance to find global optima. Handling complexity. In our contemporary worlds, where complexity abounds, meta-heuristic algorithms excel. They can handle high-dimensional problems with numerous constraints and objectives, making them valuable in tracking real-world engineering challenges. Adaptabilities. These algorithms adapt to changing conditions and evolving problems. They are well suited for dynamics optimization problems where the landscape of solution changes over time. To understand the profound impact of meta-heuristic algorithms, we can consider some real-world applications. In structural engineering, they are used to optimize the design of buildings and bridges, ensuring they are not only safe, but also cost-effective and environmentally friendly. In healthcare, these algorithms help the healthcare providers optimize patient scheduling and resource allocations, thereby improving the qualities and efficiency of care. In energy systems, they contribute to the efficient allocation of resource and the management of power grid, supporting the transitions to renewable energy sources. In transportations and logistics, they enable better route planning, fleet optimizations, and supply chain management, reducing costs and the environmental impact. Of course, no technological advancement comes without its challenges. Meta-heuristic algorithms require expertise, computational resource, and a deep understanding of the specific problem at hand. It is crucial to remember that they are not one-size-fits-all solutions. In conclusions, meta-heuristic algorithms have firmly established themselves as the key to cutting-edge engineering optimizations. They empower engineers to tackle complex real-world problems with elegance and efficiency. As we navigate an era of remarkable technological advancement and confront the global challenges such as climate change, resource scarcity, and urbanizations, the significance of a meta-heuristic algorithm become increasingly apparent. As advocated by Prof Tartibu, we must embrace them, invest in research and development, and incorporation them into our engineering practice. In doing so, we pave the way for futures defined not only by engineering excellence, but also by innovations that enriches the human expertise and safeguard the planet. Thank you for your attention, and let us forge ahead into a future where meta-heuristic algorithms are the beacon of engineering optimization excellence.
once again, congratulations, Professor Tartibu, and thank you for your very insightful inaugural address, and an equally insightful response by Prof. TC. Ladies and gentlemen, we have come to the end of our formal program. The deed is done. But you are all invited for refreshments in the lobby area where you arrived in. Thanks very much for spending the evening with us and witnessing this very, very special and moving ceremony. Thank you and good night.
The University of Johannesburg, the future reimagined.